Identify the first mechanistic step in the keto-enol tautomerization shown below. So this first structure is known as the enol because you've got the alkene and the alcohol attached to the same carbon. And we call the carbonyl form here keto to say that it is the ketone form. And although it's a bit of a misnomer, even if this was an aldehyde, we would still call it the keto form. I'm not exactly sure why. My guess is that keto-enol sounds better than aldehyde-enol. But in any case, we're going between the enol, the alkene alcohol, to the carbonyl form. So these tautomerizations can occur in either acid or base solution. So we need to look at what sort of solution we have. So let's make a quick note of that. So this can occur in acid or base, which changes the order of the steps that you need to take. Okay, so we can see here we're using H3O+, so this is certainly acidic conditions, right? So when you've got H3O+, you've got H3O+ as your acid, and then you've got its conjugate base, water, available as either a base or a nucleophile as required by the mechanism. So let's take a look at what we need to do here. So to go from this enol form to the keto form, we're essentially shuffling around some hydrogens. So we've got the hydrogen on the alcohol of the enol form that's clearly not there in the product, so we need to deprotonate there. And if we consider that here we see this 2 bonds to hydrogen, or 2 bonds to carbon, so that means that this carbon that's here has 2 hydrogens, so it's a CH2. And then if we look at the product, it's now a CH3, so we are protonating there. So we need to deprotonate here, and we need to protonate here. Okay, so when you are in acid solution, you're going to protonate first. That's what acids do. They add protons, right? If you were in basic solution, you would deprotonate first. So if you had a base, you would take off that hydrogen. Since we have an acid, we're going to protonate. And so that means we're going to protonate using our acid, which is H3O+. And so that is the mechanistic step that's being shown here in B. So you see these electrons from the oxygen are coming down to form a double bond, and this is pushing out to grab the proton. So that would give us the carbonyl, right? So now we have that carbonyl formed that we need by moving these electrons in. You still have a hydrogen attached to that oxygen. It still has 1 lone pair and a positive charge. And what you're doing here is you're swinging this pi bond out to grab a hydrogen. So that's taking that from a CH2 to, in this product, a CH3. And I'm just going to highlight the hydrogen that we added here in a different color so we can see it. So that hydrogen would be this one here coming from that H3O+. And then in your last step of this mechanism to get to the keto form, you would need to deprotonate. So you would need to remove a hydrogen, which means you need a base, and that base would be the water. So in the next step of this mechanism, your water would remove that proton. And so that would regenerate H3O+, which was your acid catalyst. So it makes sense to have a catalyst regenerated in that last step.